In number 17, we just need to complete a statement. It says, if a transversal intersects two parallel lines, then there are several things that happen. Remember, a transversal intersecting two parallel lines, this blue line would be the transversal, and these two, we'd call them parallel lines. Now, you can indicate that lines are parallel even if they don't look like they are by putting these two little, what looks like arrows, but they don't happen at the end of a line on them. Now, in this picture, we have just created 8 different angles. And there are names for these angles. Angles 1 and 2 are a linear pair. Linear pair angles add up to equal 180 degrees, so we call them supplementary. Angles 1 and 4 are vertical angles. They're congruent to one another. 2 and 3 are also vertical angles. 3 and 4 are another linear pair, as are 5 and 6, 5 and 7, 6 and 8, 7 and 8, 1 and 3, and 2 and 4. So we've got lots of supplementary linear pairs. We've also got some more vertical angles, 5 and 8, and 6 and 7. But linear pairs and vertical angles would happen even if we didn't have the parallel lines. So we don't want to use those to complete this statement. What we want to use instead is one angle from 1, 2, 3, and 4, along with another angle from 5, 6, 7, and 8. So, what's true about these angles? 1 is congruent to 5. 1 and 5 are corresponding angles. They're at the same location at different intersection points. 2 and 6 are also corresponding, so they're congruent. 4 and 8 are corresponding, so they're congruent. And 3 and 7 are also corresponding, so they're congruent. So one answer would be corresponding angles are congruent. Another thing that's true is that 1 and 8 are congruent. Those are called alternate exterior angles because they're on opposite sides of this transversal, but they're also in the exterior of the parallel lines, so not in between them. 2 and 7 are also alternate exterior angles. Then we have 3 and 6. 3 and 6 are alternate interior angles because they're between the two parallel lines and on opposite sides of the transversal. 4 and 5 are also alternate interior angles. Alternate exterior and alternate interior angles are also congruent. So those are other ways to complete the statement. The final relationships that you see are between angles 1 and 7, which are not congruent. You can see 1 is obtuse, 1 is acute. 1 and 7 are same side exterior angles because they're on the same side of the transversal and they're outside of the two parallel lines. 2 and 8 are also same side exterior angles. They're not congruent, but they are supplementary. Same side exterior are supplementary. And finally, your fourth way you could answer this is to talk about angles 3 and 5, which are same side interior angles. So 3 and 5 are supplementary, same side interior angles, and so are 4 and 6. In number 18, if you want to simplify an expression that has x's and pluses and minuses, you're going to need to factor it first. Factoring means that you're going to find values that multiply together to give you the original polynomial. So in order to do that, we need to find two numbers that multiply to give us -5 and add to give us +4. And those two numbers are 5 and -1. In the denominator, we're going to have a GCF, a common factor. If you notice, 3x and 15 are both divisible by 3. So I'm going to factor out the 3, and I have 3 times x plus 5. Now notice that we have the same factor, the x plus 5, on the numerator and in the denominator. And so we can simplify because when you divide anything by itself, you get a 1. So I'm going to have an x minus 1 divided by 3. Another way you can write that is 1/3 times x minus 1. Those are all equivalent to each other, so they're also true. The final problem we see here is number 19. This is one that we did in our very first unit of this course, and it's a linear programming problem. It's lots of words, but there are two things this problem asks you for. It asks you for the constraints, and it asks you for something called the objective function. The objective function is an equation that summarizes the whole problem and helps us figure out the answer to our question. So the hardest part of this problem is just reading it and making sure you get all the important information. So it says, a manufacturer makes two kinds of television monitors, LCD and plasma. He has equipment to manufacture any number of LCD monitors up to $400 per month. Now, when you hear that type of wording that makes it sound like a limitation, that's considered a constraint. So we can't go above 400 per month. So LCD has to be less than or equal to 400. If we keep reading, it says we can't manufacture any number of plasma monitors up to 500 per month. So we have equipment to manufacture up to 500 plasmas. So we can't go over 500. So the plasmas have to be less than or equal to 500. Then it says he can manufacture at most 600 monitors of both kinds. So the LCDs and the plasmas all together, we can do at most 600. So it's less than or equal to 600 altogether. It takes 50 man-hours to manufacture either an LCD monitor or a plasma monitor. So for the LCD or the plasma, it takes 50 hours. And it says the manufacturer has available 30,000 man-hours per month. So total for the LCD and the plasma, if we do 50 for one of them, or 50 for the other, and add them all together, the hours it takes for all the plasmas and the hours it takes for all the LCDs gives us a grand total of 30,000. So this is the information that we got out of the first paragraph. The second paragraph says the manufacturer realizes that a profit of $70 on an LCD and a profit of $50 on the plasma. So we're making $70 for every LCD, and we're making $50 for every plasma. So these are dollars. It says find the number of each type he should manufacture to realize the greatest profit. So what's the objective for this one? We want to make money. We want to have the greatest possible profit. And we make profit by making and selling these types of TVs. And it's $70 for the LCD, $50 for the plasma. It also says X is going to represent the number of LCDs, and Y is going to represent the number of plasma monitors. So now I can go back and change all these LCDs that I wrote down to X's. So I'm going to make X the number of LCD monitors, and I'm going to also follow the directions and make Y the number of plasma monitors. Now finally, here are all of our constraints. We can't spend more, or we can't make more than 400 of the LCD monitors. We cannot make more than 500 of the plasma monitors. We cannot make more than a total of 600 of the monitors. This information right here was used solely to write this equation. So I don't really need this too much anymore, because I know that I am working, or I can work a total of 30,000 hours. Now, it doesn't have to be 30,000 hours. I could give my guys a vacation. Some of them could be sick, but I know I can't work more than that. So that's where less than or equal to comes in. And so those are all of our constraints. This one right here is going to help us set up our objective function, because our objective is to make profit. So $70 for the LCDs plus $50 for each plasma is going to equal our total profit. So that's how we learn to do these. It's helpful if you kind of summarize as you read, and since this will be multiple choice, you'll be able to look at the answers and eliminate them as you go.